All right, so the first example that we're going to do for finding a Taylor series is using substitution. So we're going to find the Taylor series for f of x equals e to the negative x squared, centered at c equals 0. Sometimes we use c, sometimes we use a, but we are centered at 0. So technically this is actually a Maclaurin series, but sometimes they will say Taylor series centered at 0. So if we were going to use the original method, which was evaluate the function at 0, the first derivative at 0, the second derivative at 0, the third derivative at 0, and then plug it into our rule for the derivative over n factorial x minus the center to the n, that would be a little tedious because the first derivative of this is pretty easy. You just get negative 2x times e to the negative x squared. But then to find the second derivative, you'd have to use a product rule. And then so on for the third and fourth derivative, more product rules and evaluating. So it would get a little complicated. But we know the series for e to the x. Right, this is one of the ones that we should know. So this is something that we should have memorized, just like we memorize derivative rules and antiderivative rules for series. This is something that we should know. So we should know the series for e to the x. So what we can do here is we don't have to take derivatives or integrals. We could just use a substitution. If we replace x with negative x squared, that would give us e to the negative x squared. So if we do it on this side, we would just have to do it with all the x's on this side. And then we would want to simplify. So our first step, when we substitute using the parentheses, so for e to the negative x squared, the 1 stays the same. Then this x gets replaced with negative x squared. Then this x gets replaced with negative x squared, leaving the coefficient and the exponent. This x gets replaced with negative x squared. And then we simplify. So the 1 stays. Then we get minus x squared. Then the next term is positive because we're squaring the negative. And x squared squared gives you x to the 4th, but the coefficient stays the same, 1 over 2 factorial. Then we get negative, because we have our negative being cubed, so that would be a negative. X squared cubed is x to the 6th, and the 1 over 3 factorial stays the same. So now we just need to find a rule for this series, which the coefficients are staying the same, the denominator, so we have the n factorial on the bottom. It is now an alternating series, so we have our negative 1 to the n. And now the exponents of x are all even. X to the 0, x to the 2, x to the 4, x to the 6. So if n starts at 0 and goes to infinity, we would have x to the 2n. And our interval of convergence, since we did use e to the x to start with, is going to be the same interval of convergence, which is negative infinity to infinity. So this series, again, there should be a dot, dot, dot here because this does technically go on forever. But this series is equal to this function for all values of x. That's what that's saying. For our next example, we're going to look at one that uses sine. So we've got x sine of x squared, again, centered at a equals 0. So this is technically a Maclaurin series. So we're going to use the series that we know for sine of x. This is one of the ones that we need to have memorized. It's your odd exponents over odd factorials, also in alternating. So to get this series, we're going to have to do two things. So we're going to have to do a substitution. We're going to replace x with x squared, and then we have to multiply the series by x. So we're going to do that in that order. So we're going to replace x with x squared, and then we're going to multiply the series by x. So that means it has to get distributed to each term. So x sine of x squared. So we take this x and replace it with x squared, and then we multiply by x. So that's where this x comes from out in front. Then we have the minus 1 over 3 factorial. That stays. Replace x with x squared, and then multiply by x. So that x goes on the outside. And for the next term as well, replace x with x squared. The 1 over 5 factorial stays, and then we multiply by x. So once we simplify these three terms, we get x to the 3rd minus 1 over 3 factorial x to the 7th plus 1 over 5 factorial x to the 11th, and so on. So finding a rule for this series, if we start n at 0 and go to infinity, we're alternating. So we have our negative 1 to the n. The denominator is still going to be 2n plus 1 factorial. That's not changing. And now the powers of x's are a little tricky. And if you're not sure, to get from 3 to 7 to 11, if you don't see the pattern, use the original rule that we started with. If you replace x with x squared, that means you have to multiply this exponent by 2 to get 4x plus 2. And then we're also multiplying by x. So if we have x to the 4x plus 2 times x, you've got to add an additional number to the exponent to get 4n plus 3, or 4k, whatever variable you're using. All right, you can move on to the next video.